Goethe's investigations took place in the world of pictures because he described what he saw. That is why his prism experiments differ markedly from Newton's. Newton theorized about an isolated ray of light, but there is no such thing in visual reality. We can see as much by looking more closely at the first part of the classical experiment. The sunlight passes through a small hole and strikes the opposite wall. The result is what we call an optical image, a picture of the sun. It's a principle called camera obscura, dark chamber, and known in Europe since the Middle Ages. When the light from the sun passes through the hole, an image of the sun is formed. What we see is not an image of the whole. The sun contains its own image. No matter how small the hole, and no matter what shape it is, a round image of the entire sun will always be formed, surrounded by the darkness of space. It is not an isolated ray of light. The bulb in the camera obscura emits light into the room. Some of it escapes through the tiny hole in the wall and strikes the screen. Not only is the image of the bulbs depicted through the little hole, but the darkness around them too. That is why we see the picture of the arrow. The light always carries a picture of its own source. Here, the source is the entire radiant image of the tree, the yellow field, and the blue sky. Newton knew that the shining dot on the screen was a picture of the sun. But when he tried to investigate why colors arose when the sun's image was refracted by the prism, he left visible reality and the image of the colored suns. He did so in order to seek a proof of why colors arose based on the contemporary perception, that everything in the universe consisted of tiny, invisible building blocks or atoms. He was looking for the atoms of the colors. Newton imagined that light could be split up so that just one isolated ray passed through the prism. He defined his theory of colors using an objective yardstick, just as science today strives for objectivity and defines the colors in terms of different wavelengths. Science can explain colors without observing them. The natural sciences show no interest in darkness. It is merely the absence of light. But it is our ability to see and interpret pictures that links us to the world we live in. Pictures that arise in the encounter of light and darkness. Newton presented a theoretical interpretation of the prism experiment, but Goethe chose to examine what he actually saw. He began to explore the image of the color spectrum. He replaced a white square against a black background for the round sun. When the image was projected through the prism, he saw two color spectra, a yellow-red one above and a cyan-blue-violet one below. He observed that it was in the horizontal boundaries between light and darkness that colors were born. He called the two spectra boundary colors. The boundary colors may also be seen in the sky where day meets night. But the green from the Newton spectrum is not present. We send the white square against a black ground through a special prism. This prism can open and close. This enables us to observe the birth of the colors as a dynamic process as the image is refracted. When the prism is closed, the image passes straight through, just like a window. When the prism opens, the image is refracted and shifted upwards. We now observe the way the boundary colors arise as the prism opens. Yellow-red below, blue-violet above. The yellow and blue marginal spectrum arises, culminates, and disappears as the image is shifted. If we substitute a bar for the square, reducing the distance between light and dark, something else happens. As the image shifts, the two boundary colors arise as they did earlier, but because the gap between them is smaller, they meet, and yellow and blue mix. The color green appears. We observe that Newton's spectrum only arises as a particular phase of Goethe's two boundary colors, when they are close together. It is the distribution of light and darkness in the image that determines whether Newton's spectrum arises. Newton concentrated on a theoretical definition of the colors. Goethe explored them as dynamic processes. Everywhere, in prisms, in celestial phenomena, in nature, he observed and recognized the birth, culmination, death, and rebirth of the colors. He sought general laws. One of them was that colors arise where light and darkness meet. If we look at the black tree against the white background through the prism, we recognize the Newton spectrum with its bright blue, green, and red. But where the black branches are very thin, we also discern other colors, namely pale yellow, magenta, and cyan. The image that produces Newton's spectrum is a white bar against a black background. In the black bar on the right, the boundary colors switch over so that red and violet meet and merge into magenta, the way yellow and blue merge to form green. Here is the dark spectrum that Newton found, together with the light spectrum that Goethe added. The light spectrum and the three light colors. The dark spectrum and the three dark colors. Goethe incorporated both the light and the dark spectra into his color wheel. In the color wheel, we recognize all the general laws the colors abide by everywhere in nature, the nature we are a part of. Because recognition is harmony, Goethe calls his color wheel the harmonic color wheel.